Okie dokie. Now we're going to start work on the additional exercise, and this is the one that we started in class. So I'm going to go pretty quickly here because we've done quite a bit of this, and I want to start by sort of organizing our variables. So again, this is a projectile motion problem, as we talked about in class. And so in this problem, we know that ax is equal to 0. And I'm going to draw my coordinate axes just like I did in class, x hat and y hat. I think that's how I did them in class, which means that ay is minus g, okay? Okay, and so I'm going to do what we did in class. I'm going to organize variables, x direction, y direction variables. I'm going to set my origin to be right at the base here. Well, I guess technically it's kind of up here. It's wherever he sort of initially lets go of the protein bar. So we've got x0, x final, v0x, v final x, ax, and t. And the initial point is right when it leaves his hand, and the final one is right after his friend catches it. All right. y0, y final, v0y, v final y, ay, and t. And again, I'm going to organize, I'm going to collect our variables. And again, we did a bunch of this in class, so I know that this is 0. This is 0. I know what my final position is, and I know what my final position in x and final position in y is, because I can draw my triangle here, 39 degrees, 8.6, and so I can find x final, y final. I can do all of that, right? And I can do the trig to make that happen. X final is 8.6 meters times the cosine of 39 degrees, and y final is 8.6 meters times the sine of 39 degrees. So you can plug those in. But wherever those variables show up, we know that we can find those. And again, our job in this problem is to find the initial velocity. And when we say initial velocity, we mean the components in this case. So I don't know what it is, but that's what I'm after. And I know my acceleration in the x direction is 0, and so as discussed in class, that means the final velocity in the x direction is just the initial velocity in the x direction. It's not the case for the final velocity in the y direction, but we know that we want the protein part to reach our guy traveling horizontally, so that means the final velocity in the y direction is 0. Ay is minus g, and we can actually start trucking on this thing. And so this is a constant acceleration problem, right? This is a projectile motion problem, and so a good guess are constant acceleration kinematics equations. And I'm going to cherry pick a little bit. I'm going to start in the y direction, and I'm going to use the fact that v final in the y is v initial in the y plus ay times time. Now I don't know the time, but it turns out in this problem I want to solve for time and plug it into something else. I know that my final velocity in the y direction is 0, and I know that ay is minus g, so 0 is equal to v0y minus g times time, and so that means that the time is v0y over g. And again, it's not obvious right away why I do that, except I know that my final position in the y direction is where I start, plus v0y times time, plus 1/2 ay t squared. And so it turns out that I know some stuff here, okay? And in fact, I know the final position in the y direction. I know it starts here at 0. It doesn't start from rest, can't, but I can plug in for time. And that actually turns out to be really helpful, okay? So when I do that, I get y final is equal to v0y, which I don't know, times time, v0y over g. I'm just going to substitute in there, plus, well, ay is minus g, so I get a minus g over 2 times t squared. Well, t squared is v0y over g squared. And so here's it gets a little interesting. So if it's not obvious yet, we'll sort of work it all out. v0y squared over g minus, well, I have a G and a G squared here, and a 2, so I get 1 over 2G times V0y squared, and I have 1 minus 1/2. That's just going to be, well, I'll write it down here, because it's important. Y final is equal to V0y squared over 2. Okay. And so that's important, right? That tells me that if I rearrange that expression from the previous page, I get V0y squared is equal to, oh, I forgot a G, sorry. V0y over 2G is 2G times y final, or V0y is equal to the square root of 2G y final. I know that, I know that, and I know that, which means I can find this thing. And so we're golden here. Okay, I can actually plug and chug and find that. Okay. Now the other thing that's interesting about this is that I go back. I found the time it takes to get to the top based off this expression. So once I plug this in, I can find it. All right. And further, I remember that since the acceleration in the x direction is 0, this means that my final position is just my initial velocity in the x direction times the time. Or, rearrange, v0x is equal to where I end, which I know, divided by the time. But time is just related to the initial velocity in the y direction. So I get xf, I get a g up top, I get a v0y in the bottom here. And so I can calculate this. v0y is the square root of 2 times, well, I'm just going to use 10 meters per second squared, because why not? And my final position in the y direction is 8.6 meters times sine of 39 degrees. And I think that when you plug that in, we get 10.4 meters per second. And when I plug that into here, v0x is g times x final, which is 8.6 meters times the cosine 39 degrees, divided by 10.4 meters per second. And when you plug that in, you find v0x, and I think if I didn't make a mistake, is 6.4 meters per second. And of course, if I wanted to, I could find the magnitude, because v0, magnitude of v0 is just going to be the square root of v0x squared plus v0y squared, if I wanted to do it like that. Oops, I hope you can see that. And I can find the angle. Okay, if I wanted to find, if I said this was v0 and this was some angle phi, phi would be the tangent inverse, the arctangent of v0y over v0x, and we are golden. That's a big smiley face.